Okay, so scientific notation is a way of writing really large numbers, and these numbers usually occur in the sciences, as the name would imply, such as the number of atoms in a molecule or the distance from one planet to another in terms of miles or kilometers or whatever unit. So the purpose of scientific notation is write large numbers in a more compact form. Okay? The rules for writing numbers with positive exponents, and it's going to apply to most of the rest of what we talk about, is number one, we're going to move the decimal point until we get a number that's between 1 and 10. Okay? And then we're going to count the number of decimal places that we moved. So for example, 1,400,000 decimal points here, and we're going to move the place, we're going to go backwards 3, 4, 5, 6 until we get to a number that's between 1 and 10, which is going to be 1.4 here. So that's going to be 1.4. Remember that each of these zeros or each of these places represents the number 10. So times 10. And we move 6 places, so that's going to be 10 to the 6th. Okay, 189,000. Again, we're going to move 1, 2, 3, 4, 5 until we get between a number that's between 1 and 10. We're at 1.89, and we went 5 places. Okay, convert to standard notation, 1.3 times 10 to the 4th. Okay, well, 10 to the 4th power, 10 times 10 times 10 times 10 is 10,000. So it's 1.3 times 10,000, which is just 13,000. Okay, and if you want to check, go backwards, decimal place here, 1, 2, 3, 4, 1.3 times 10 to the 4th. Okay, so 13,000 is the answer here. Okay, scientific notation with negative exponents. So all the same rules apply as with positive exponents. I don't like the way this is written over here. If number begins right of decimal point, okay? This number begins right at the decimal point. Same with this one, right? The exponent will be negative, okay? When we're dealing, all these numbers over here, see the decimal point over here, they're all left of the decimal point. Over here, they're all right of the decimal point, so they're going to be negative exponents. Okay, so again, we need to get a number that's between 1 and 10. So we're going to move decimal points here. We're going to move it 1, 2, 3, 4, 5 spots. So this is going to be 8.8 times 10 to the negative 5th. Negative exponent because we're right of the decimal point. Okay, next one. So we're decimals here, moving it 1, 2, 3, 4, 5. Okay, so this is going to be 3.12 times 10 to the negative 5th. Okay. And number 6, convert to standard notation, 6.02 times 10 to the negative 4. Well, 10 to the negative 4 1.0 times 10 to the negative 4. That's going to be 0.00004. Okay, you can check that by working backwards. Sorry, 0.00, that should be a 1. Okay. So 6.02 times 10 to the negative 4 would be 0.0000602. Okay. Okay, next thing, multiplication with scientific notation. All right, so step 1, multiply the whole numbers together. And then we're going to multiply the powers of 10. So we're going to do the wholes separately from the powers of 10. In example 7, the wholes are 4.3 and 2, which makes 8.6. Okay. Then if we multiply the powers of 10, we have to use that product rule of exponents, which you should remember is add exponents. Okay. So this is going to be 8.6 times 10. We've got an exponent of 9, exponent of 6, that makes 15. All right. And again, we have to remember that our whole number must be between 1 and 10. Anything in scientific notation, the whole must be between 1 and 10. If it's not, we're going to have to rewrite it. All right, so number 8, when we multiply the whole numbers, 7 times 5.3 is 37.1. Times, we've got a 10 to the negative 2 and a 10 to the 6th. That's going to be 10 to the 4th. Okay. The problem here is this isn't in proper scientific notation. This has to be between 1 and 10. So we're going to have to move the exponent one place. So this is going to be 3.71 times 10. That's going to be to the first. Okay, times 10 to the 5th, okay? So we have a 10 to the 1st, sorry, 10 to the 4th, which that's going to make the 10 to the 5th. So your answer here is going to be 3.71 times 10 to the 5th. Okay, number 9, so we're going to multiply the wholes. 8 times 6.2 is 49.6 times 10 to the negative 3rd and 10 to the 8th makes 10 to the 5th. Okay, but this isn't in proper scientific notation. We're going to rewrite as 4.96 times 10 to the 1st. Okay, times 10 to the 5th. And that's going to make our answer 4.96 times 10 to the 6th. Okay? Last thing, dividing with scientific notation. Okay? Works just like the multiplication with scientific notation. Okay, so here we're going to do the whole number separately from the exponents. 5 divided by 2, that's 2.5. And then we're going to have to use our quotient rule, which means subtract the exponents. Okay, remember when we're dividing exponents, we're really subtracting. So this is going to be 2.5 times 10 to the 5th. Okay? And this is between 1 and 10, so we're good. Nothing more to do here. All right, but number 11, when we divide the wholes, 5.4 divided by 9 is 0.6. and then we have times 10, negative 7 minus 9 to the negative 16. Okay, so we're going to have to rewrite this as 6.0 times 10 to the negative 1 times 10 to the negative 16, which is going to simplify to 6.0 times 10 to the negative 17.